Would you love to learn how to solve mathematical problems involving indices like this? Then stay tuned because I'm going to be showing you how to do that. I'm going to be showing the easiest and simplest way to do so. Without further ado, let's get into the classroom. Previous class, we learned about interpretation of the laws of indices. But in this class, we are going to be learning how to apply those laws in solving mathematical problems. So, some examples for understanding. For this first example, when you're given something like this, you just need to think what law resembles this. If you remember where we had something like this, AM times AN equals to AM plus N. So since we have the same basis, we simply apply this law. So we are going to be having, we pick the base, one of the base, and which is 5, and then the index or the exponents, and sum them up. So we are going to have 3 plus 4, which is equals to 5 to the power of 7. So whenever you have the same basis and you have multiplication, the next thing you do is to what? Add the exponents. That's exactly what we've done. So let's take a look at the second example. In the second example, we have 7 to the power of 9 divided by 7 to the power of 4. So what do we do here? In this one, if you take a look at it, it looks like the law I already interpreted in the previous class. Well, since we have same basis, what we are going to do, we are going to be subtracting the exponents, okay? We are going to be subtracting the exponent. So whenever you're multiplying or dividing number in the same basis, all you do, pick one of the base since they are the same, and then you subtract the exponents. So we are going to say 9 minus 4. So let's look at the third example. So this third example is going to test our knowledge on understanding distribution, okay? What it simply means is that this can be multiplied by this, okay? 6 cubed can be multiplied by what? Can be squared. That is what it simply means. So here's what we are going to do. We are going to have 6 to the power of 3 being multiplied by 2, okay? And then when we do that, we're going to have 6 raised to the power of what? 6. So that's exactly how we go about solving this. So how about something like this? In looking at this, remember the law that says anything raised to the power of 0 gives you 1, regardless of what it is. Even if it's a fractional number, it mustn't be a whole number. So we have 7/9 to the power of 0. It simply gives us what? 1. Okay, now we've done this. Let's look at questions that are a little bit higher than this or complex. How about something like this? How do we go about solving it? Now, whenever you're given a question like this, here we have both the symbol of multiplication and division. Here's what you do. Note the basis. Ask yourself, first of all, can we get identical bases? Of course, you can see that the 6 and 6 are in the same base, all right? And we have 5 and 5 are in the same base. So here's what we are going to do. We are simply going to rewrite this as 6 raised to the power of 2 plus, now you have to be mindful of this minus 3, okay? Then you open the bracket and put minus 3, then close the bracket. Then after that, we are going to have times, now you know that 3, any number raised to the power of 0 is 1. So 3 raised to the power of 0 gives us 1 over, then here we have same basis and we are dividing. So we simply subtract the exponents. So we are going to have 5 raised to the power of 3 minus 6. Okay, so now we've got into this table. We are going to have 6 now, 2 plus minus 3. Now, plus times minus gives us minus. So we are going to have 2 minus 3. Now, when we have 2 minus 3, it's going to give us minus 1. And if you multiply it by 1, it's still going to give us 6 to the power of minus 1. Then we're going to have over, then 5, 3 minus 6 gives us minus 3. So here we have 5 to the power of minus 3. Now, when we have something like this, we can't leave our answer this way. We can further simplify it. If we remember well, we have a law that states m minus 1 equals to 1 over m to the power of 1. M to the power of negative 1 equals to 1 over m to the power of 1. We do not straight away multiply negative indices. We must convert them to this form. So that's exactly what we are going to do here. In doing that here, we are going to have 1 over 6 raised to the power of positive 1, okay, divided by 1 over 5 raised to the power of positive 3. Now, by the time we get to this stage, remember, whenever you're using a fraction to divide a fraction or a whole number to divide a whole number, we are going to invert this, okay? So we are going to have 1 over 6. Then in doing that, that changes the sign. So we're going to have times, and then the denominator becomes the numerator, 5 cubed over 1. Now that we have this, we are going to have 1 times 5 cubed. 5 cubed means 5 times 5 times 5. So when we do that, we are going to have 5 times 5, 25 times 5. We have 125 over 6. So let's check, can we reduce this to the lowest term? If we try out 3, it's not going to work. We are going to be having remainder. So we leave our answer like this. Okay, so let's take a look at this very example. In this place, we have 64 raised to 1/3. Now, whenever the exponent is a fraction, it introduces what? The root sign. You should bear that in mind. So what it means, we are going to have 64 here, and then what you're going to have, the denominator is going to be here. You simply put the denominator here, while the numerator will be raised to its power. In this case, we have to the power of 1, okay? So when you talk of cube root, you're asking, what number do you multiply 3 times to get 64? The cube of 64 is simply 4. 4 raised to the power of 1 is still 4. So our answer is 4. How about this third example? How do we go about solving it? In this case, we have this dividing this, okay? And they both have fractional exponents. So here's what we do. We are going to have this in the root form, and we're going to have this in the root form. So when we do that, we're going to have 216. Remember, the denominator takes this position. So we're going to have 3. Then we are raising it to the power of 2, right? And then we divided by, we are doing the same thing. We are going to have 81, and then here we are finding the fourth root raised to the power of 3. Raising it to the power of 3. So what number do we multiply by itself 3 times to get 216? That is 6. So the cube root of 216 is 6. Then we have square, okay? Then divided by, what number do we multiply 4 times, okay, to get 81? So finding the fourth root, we have 3. Because when we say 3 times 3 times 3 times 3, that's going to give us 81. So we have 6 square and we have 3 cube. So now we've gotten to this stage, we are going to have it this way. 6 square is what? 36. Then remember, this division sign still means this over. Then what is 3 square? 3 square is 27, okay? So let's look at this. Can we further reduce it? Yes, we can. We have 9 goes here, 3. 9 goes here, 4. So we have 4 over 3. You can leave your answer like this, or you want to put it in mixed fraction or mixed numbers. You're going to have 1/3. So we're going to have 1/3 as our answer. So this is it on introduction to solving problems involving indices. Do watch out for the part 2 of these lessons because we are going to be diving deeper to treat more complex questions. If you got value from this lesson, give me a thumbs up. Do you love to see more videos like this? Hit the subscribe button if you've not. Turn on the notification bell so that you can be notified whenever I upload content like this. And don't you ever forget, math can be easy. Thank you for watching.